But it also just like I think like if you read ESD print, it's better than that. You know what I mean?
Similar, I would say, but this is still okay. So P is a variable. Okay, we see new printer, whatever that is. It do print line on it. Then you have here. I'll explain what this does.
Checking the error.
Sorry.
Check the error.
Well, here it calls write, and write actually returns the number of characters written, I guess, by the number by n, and it returns an error, and then.
Now that you explain it.
And actually that n and that error those are variables in the function which are from here, from return. I'll explain that now. Okay, so I can make my own function, whatever, I can move this print line into there. I can call of course, yeah, that works. So in Go, functions can have arguments. So if I do a string, and I print here a and I do here a test. First thing you'll see is argument and type are the other way around for most languages. So string comes behind instead of in front. So most languages you would write it the other way around. You would write string, but in Go it's the other way around. This of course works as well. Go also has return stuff, so of course we can also say it returns a string. So now I say I'm going to just print the result of this, and we're going to return foo plus that works. Strings you can just append to each other, so it's not like C where you have to use cut or whatever. It's just strings are first class values, as you say. I can also return multiple stuff. So in Go, a lot of functions would return an error as well. And Go has multiple return values. So now I'm saying the function doesn't just return a string, it returns a string and an error. I can do a nil, for example, as a null pointer error. Then I can do like whatever, x and error is a test. If the error is not nil, then I'm going to panic, because then I don't know what to do, and otherwise I print x. Of course that works.
But can you use like FFT, print ln, a something?
No, okay. In this case it's gonna work, sort of, I think. Yeah, so in this case it prints the string and the nil, but that's because the print line function accepts multiple arguments. And then I would really have to put it into variables. So then I could also do this. If I'm not interested in the second variable, I could do this. So I assign it to the underscore variable, which is just a name for nothing, just ignore it. That would also work like this.
But I cannot use the underscore as a variable, can I? Just
and now, no, you cannot read from it. You can basically only write to it to dump something in. It's like def null or something like that. Oh, another thing that's important in Go is the automatic type assertion. So here I do a double dot is. Makes Go automatically infer that x is going to be a string, because the function a returns a string and an error, so a is going to be a string as well. I can also say var x is well, if I say an integer and I do a normal assignment, then it's going to say, oh, cannot assign string to x because it's an integer. But if I do string here, then it's going to be fine. So if you already have a variable of a certain type, then you use the normal is. If you don't have a variable yet, you usually do it like this, because then you can omit the variable declaration. I say, let's go to something more interesting. Go routines. Go is really easy to parallelize, to do stuff parallel. And I'll show that by, I don't know, let's do a function, I don't know. Like I said, I didn't prepare anything for this. I'm going to make a function A, which is going to loop. Then you also see how a for loop works, which is basically the same as any other language. We're going to import the time package. I'm going to print like foo, and then time.sleep, time.second. Okay, so if I now execute this function, okay, maybe I should make it a bit faster because now it's just gonna print for 10 seconds. Let's make that 4 seconds or something. But you see, you get the idea. It's a for loop, 4 iterations. Every time it prints foo and it sleeps for 1 second. Now, if I do another function, func b, this function is just going to time.sleep for a second, and then it's going to print bar, whatever. Now, if I do b after this and I run it, of course, it's going to print like foo, 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 bar. If we want less, then I can also say like half a second, whatever. So these functions run after each other. What if we want to run them at the same time? Well, then I can say go. Go executes the function, but it executes it on a different thread. Not really a thread, but basically a thread. So it's parallel. I'm going to add one other thing here, because now if I execute it now, it's going to print foo, 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 bar, and then exit. So the fourth foo is actually missing. Why is that missing? Because this one goes into a different thread. B is going to execute, that's going to sleep for a second, print, return, and then my main returns. And when your main returns, your program ends. So this other thread, the A function thread, doesn't get to run anymore because my whole program stops. If I do B go as well, it's probably going to print nothing, because then A is started in a different thread, B is started in a different thread, my main function returns, my program ends. If I run this, it doesn't print anything. So to prevent that, I can, for example, let's say time.second times, let's wait for 5 seconds. Now if I execute this, what's it going to do? It's going to execute this in a different thread, so this is going to print foo every half a second, so it prints 1, 2, 3, and then at the same time as the third one, this one slept only for 1 second, it's going to print bar. So they're actually doing this in parallel.
I have a question.
Yeah.
So the first, so if you see that actually the A and B are running in 2 different tracks.
Yeah.
Right? So then A is running every half second. So
yeah.
And compared to that, B is running every second, right?
Yeah.
So I would expect 2 foos and then bar and then down.
Yeah, I would expect 2 foos, then either a bar or a foo, because both of them at that point has slept for 1 second. Oh no, wait, you're. Yeah, okay, yeah, because I'm printing before the sleep. What you're thinking of is if I print after the sleep. Now it's going to be 2 foos, then either a foo or bar, and then another foo.
Yes.
Yes. But it could also, in theory, be foo, then bar, then foo. Because it's a race condition between the two. If I do here time.second, then we never know which is going to come first, the foo or the bar. This time it's the bar, and then it's probably always going to be the bar, because... But it could be foo in theory. Because it could be that this one doesn't get the CPU for a bit because it's a different thread, and this one gets...
Only one thing, the fact is that A is getting executed before B, so I would expect A to execute first, but here B is getting executed.
Yeah, because you're saying like start that function in a different thread, and then it's just your CPU which decides if it is going to run, or your OS, if it's going to run that thread now or the other thread or stuff like that. In the Go playground, it's probably always the same, because the Go playground is deterministic. So
single thread.
is it single threaded? I'm not even sure if it's single threaded. I just know it's fully deterministic. Like, you don't have any possible way to do anything random in the playground, or you don't have any file I/O. You don't have any other type of I/O. If you get a random number, it always has the same seed. Like, they make sure that every execution of the playground is always with the exact same result. So if I start another playground session, if I import random number generator and I do rand.int a random number, it's always gonna, no, random number from 0 to 100. 81, 81 is always going to print 81. If I do the time package, I print time.now, so the current time is always going to be, I don't even know what it is. 2000, yeah, whatever.
Why is that? This is not supposed to print out the server time.
It's, you would think so, but this also makes it possible. So every program always runs in the exact same way, so they just also cache the output of programs. So if I run this program again, it's not actually going to run the program again, it's just going to give me the exact same cached result.
So basically they're
and
keeping this code as a hash and then running
yeah. So if I do share, I can see that hash. So I can zoom in. So this is the hash for this code. But it also makes it easier to share stuff with each other, because you know if someone executes it later, they're just gonna get exactly the same. If you would have a different result, then it would complicate some things. Getting back to Go routines, so they actually run at the same time. I can show this. I can do var, let's say we do an integer here in the global scope. And in this one, I'm going to loop forever. A forever loop looks like this in Go. Then every millisecond, I'm going to increment I. So I'm incrementing this global variable. And then in B, let's say 4 times, I'm going to wait for a second and I'm going to print I. Run this. So now you see 0, wait, why? Oh, sorry. So Go doesn't complain about that. So here you see I used the global variable I, but here in my loop I also used an I. So this I is now actually my loop counter and not my global variable. So this one overshadows, and that's just allowed. No error, no nothing.
Okay, then what happened to the global one? It's not really used right.
Now the global one only gets incremented by this thread, and here nothing. I'll get to that. So now I changed this to J. So now we're gonna see, like, yeah, exactly what you expect. It increments every millisecond. So this one runs 1,000 loops, while this one runs 1 loop.
So,
now I
so
can.
that means it's synchronized, right? Somehow.
I'll get to that, because actually this is bad code. I can also do it like this, like without any sleeping in the other one. Okay, that's not allowed in the playground. In real life that would be allowed, so I can, let's just run it in real life. Zero, zero, zero. That's a good question. Why is it printing 0, 0, 0? I think here we're running a bit into an issue where Go says, okay, this is bad code. I can, because right now I can also do this, go run -raise. It's definitely gonna give me an error. So it's actually saying here, this is with a raise detector, and a raise detector, okay, it's not safe to change one variable, change a global variable from one Go routine and read it or change it as well from another one, because then at the same time they're trying to access it, and that can result in all kinds of bad stuff. So Go is actually telling me here, there's a data raise here, one Go routine was reading from it and another one was writing at it at the same time. What I should actually write is here. So that stuff, like with JavaScript, you never have this issue, because with JavaScript, all your JavaScript is executed in a single thread always, so you don't need any primitives or whatever. Here we're going to need sync the atomic package. And now I'm going to make this an int32, and I'm going to say, I'm going to do this, and on here, so I'm going to use the atomic package, and atomics are actually instructions in your CPU that make sure that if you do something with it, like for example this add, this increment, it will only do it on one core, one thread at the same time. So this is actually an instruction in your CPU that makes sure that it writes like a memory barrier, it's called. So it makes sure that the piece of memory that I is occupying is only read to or write to by one at the same time.
It's thread safe. That is doing the
Yeah, it's basically thread safe. So now if I run it also with the race detector, it's going to print some number. So apparently in 1 second that for loop got to increment I by 14.5 million times. So
I don't quite understand. So it's considered safe when it only runs on one processor?
this is considered safe now because I'm using the atomic instructions.
And the atomic thing makes it run on one processor?
No, it's so normally if you increment something in your CPU, that's like an increment instruction. It says increment the value in this memory location. If two CPUs do that at the same time, that's a race condition. Then your CPU is going to decide which one of the two it's going to do, or maybe it's just going to discard one of them completely. If you use an atomic increment instruction, it's two instructions. It's a what's called a write barrier and increment instruction. And the write barrier says the next instruction that's following should be the only one that's executed on this memory location for this time. So then your CPU, if two of those increments are at the same time, or read in an increment, your CPU is going to be, oh, okay, I'm doing this one first. When that one is done, I'm letting the other one run. Well, if you don't have that write barrier, it's just going to say, okay, I run this one, the other one just discard it or just do whatever, because it's not defined what it's going to do then. It's called a write barrier, really low-level stuff. Another thing, another way in most languages how you would write this stuff is with a mutex. So, does everyone know what a mutex is?
Yeah. So semaphores.
Yeah, semaphore, mutex, sort of related.
At schools they typically call it semaphores.
Yeah, so mutex is has lock and unlock operations, and the idea is that only one thread or only one Go routine can lock at the same time. So if I do here .m.lock, m.unlock, you see I removed that atomic instruction. Here I also do m.lock, m.unlock, remove the whole atomic thing here as well. This is also gonna run.
How do you make it lock?
No race condition, but wait, I'll explain how it works in a bit. You see here it incremented with the atomic instruction, it did 14.5 million increments. With the mutex, it only does 3 million increments, so it's a lot slower, but you can do a lot more. So mutex makes sure if this m.lock is executed, then when I'm inside this code, no other code can lock. So if this one is being locked at the moment, and this one tries to lock it, then, wait, is it big enough? Then this lock will just wait until this one called unlock. So I can actually show that by, I can make another Go routine.
If you didn't have the lock and B, would that be a race condition?
Yeah, then it's still a race condition. If I don't have the lock here, then it's basically exactly the same as if I don't have the lock here either. Because now this is just gonna lock and prevent no one else from doing anything, because no one else is using the lock.
So basically when you use the mutex, you basically put 2 blocks of it down or something.
Yeah, or multiple. So what I show now, I write another Go routine C. I'm going to execute that in the background as well. This one I'm going to do, wait, let's say...
Sorry, before you complicate it to the next level, I have one more question.
Yeah, of course.
So the A and B, right? So I can understand that you're locking and unlocking A, but that's completely cool, okay? But I would assume that in B, if you remove the mutex locking,
yeah,
then the print I, when the loop is going on, the CPU should at least give this one somewhat one opportunity to read I.
Yeah, it's gonna get an, it's gonna get an opportunity to read I. If I execute this, that's gonna be completely fine.
There's also chances that you might read at
But
that places that
it's, yeah, here, it's executing fine. It's just a race condition, because now you're reading a memory location that was just written to without any synchronization. So in your CPU, that's also, it works in this case, but it's kind of undefined behavior. Because that memory location is being written to at the exact same time as you're writing from it, and maybe like the first 2 bytes are already written to memory because the integer is 4 bytes. The first 2 bytes are written to, but the second 2 bytes aren't being written to yet, so the value is not correct.
I would get some coverage.
Yeah, it's possible. Yeah, in theory, everything is possible there.
Okay.
Well, not everything, but it's undefined behavior to do that without any locking.
Thanks.
How do you make it lockless?
With that atomic instruction that I just did, that's on write barrier on your CPU, which is not really a lock. That's the fastest way to do it. But yeah, but atomic instructions is only possible on like 4 or 8 bytes at the same time. So if you have like a big data structure or something, then you cannot use atomics for that, because that atomic only for integers basically. And that's something that's in your CPU. So what I'm going to show now, this C, I'm going to sleep for half a second, then I'm going to lock it, then I'm going to sleep for another half second, and then unlock it. So what I expect now is this one tries to write as fast as it could, was like 3 million times per second. This one every second tries to print the value, but now we have another Go routine that's going to lock the mutex for half a second. So I expect now that this one only gets to increment it for half a second, so gonna print like 1.5 million values or something like that. Yeah, that's about 1.5 million. So now we see that while this Go routine is keeping the lock, like only one person can have the lock, this one keeps the lock for half a second, and then the other ones in that half a second can't do anything.
How do you like visualize that what do you call it, blocked?
The locks that, yeah, critical sections, it's sometimes called in other programming languages. Or how do you visualize it? Yeah, this is the difficult part of multi-processing, multi-threaded programming, that you have to have every data structure that's shared between different threads, you need to somehow lock, and if you want to keep things fast, you always want to have the minimum amount of time that you keep that lock. So yeah, that's a difficult part of that.
There's no easy way to...
That's why PHP doesn't have that issue, because it just one process per page or per call or per whatever. JavaScript, Node.js, they fixed it by just executing all the JavaScript code on one thread, so you never have that issue.
We can run it in cluster.
Yeah, exactly. But in cluster, you still don't really share the code, the global variables. You have to communicate. You could do exactly the same as cluster with Go, but
yeah. But how about PHP? You say that PHP doesn't use one core only. Do you say?
Yeah, PHP is usually even one, no, not really one process per, but it's basically one execution context per request.
Right.
Yeah.
It has the worker, but the worker can't use multiple cores.
Yeah, it can, but it's only one execution context. There's no global variable that is shared between requests in PHP.
No, but it's better because of that model. I mean, request.
It's easier, yeah, but this makes with Go, those Go routines makes doing stuff parallel really easy.
Well, it depends on the way you need to do it, I guess. I have a stupid question. This is probably really dumb. Is print line itself like a mutex? Because you can't like print over each other, can you? When you're doing a print line. It somehow seizes.
Yeah, but that's
line or
yeah. At some point, it has like a mutex, but that's all the way in your operating system. If you do print line, at some point it's going to do a write system call to your like std out file descriptor, which is the process that prints stuff on the screen, and then in your kernel, it's the write system call is going to do a mutex. Yeah, but that's all the way in your kernel of your operating system.
Because I just mentioned that because you know, sometimes when you're using CLI apps, that the whole thing seems to be slowed down just because of what they're printing.
Yeah. No, and that's definitely because there's locking involved in that. Yeah. Good examples. Okay, let's write an example. I'm going to write a really simple web app, because why not? So Go has everything in the package, in like the standard library. If I want to write a web app, I don't have to do anything weird. I import the HTTP package. Let's remove some of this.
One clarification. We have seen the locking and we have seen the atomic.
Yeah.
Two packages kind of doing the same thing. So when do you recommend using which one?
Well, like I said, atomics are a lot faster, but it's the only operations that you have on like atomics is to increment a variable, to load a variable, to you have atomic compare and swap. Actually, I can show sync atomic. So you only have like a couple of things that it can do. It can add to an integer, it can compare and swap, which basically means that it says something like, if the value is equal to whatever, then put in another value.
So if you're like implementing a crazy, counter.
Yeah, a counter I would always do is this, because it's much faster. Okay. Maybe this is nicer. Let me go to the plane. Wait, I just use this.
Sorry, I'm stopping you here.
Maybe this is more fun. Do I still have?
I think you can have a mutex like in a struct, aren't you?
Yeah.
I've seen that pattern.
Yeah. Mutex is okay. So we can do this.
It's way more sensible.
Let's keep this. We have I. We're going to implement our own mutex. That's also interesting. So I'm going to call type mu is a struct. This is how you define like a struct in Go. And I'm going to implement the mutex. I'm actually going to also use an integer. And then I'm going to do, this is how you define a function on a struct. So this is the syntax for you have a struct mu, which has a member L, which is an integer, and this is the function lock on that struct. So it's a bit weird syntax. In other programming languages it's completely different. Okay, so I'll explain pointers in a bit. So I'll explain now a bit. I'm making this a pointer because I'll write first. I'll write my code first. So to lock it, I have this integer. I want to make sure no one else has locked it at the moment. So let's write a for loop first. If it's not locked, I want to lock it. So we're going to use compare and swap. I'm doing if. So if m.l. Wait, let's call it lock, it's maybe a bit better. And I need to do this. This is, so the pointer to the integer, then old new. So if it is a 0, then I'm going to put in 1. If this was a 0, so the return value, it returns true if it's swapped. So I can just do this. Return. So this is my lock, and then I'll explain a bit how it works, if maybe someone already understands it. And unlock is much simpler. I'm going to atomic dot, what is it, put or store? Store. Store and m.lock 0. This is how I would implement a mutex with using atomics. So I have a lock, which is an integer.
Why didn't we use a boolean?
Boolean? Because there's no atomic operations for a boolean, only for integers. So it's basically a boolean, yeah. So I'm saying 0 is unlocked and 1 is locked. If I want to lock, I have to tag, does anyone else have to lock? So I'm going to compare and swap, which basically means check that variable. If it's equal to 0, then this whole function is going to return true, and it's going to put 1 in there, and that's one atomic operation. So it basically does this. If m.log is 0, m.log is 1, return true, else return false. So this one function basically does this code, but then in an atomic way, that there's no race condition and there's no problem. So now, if log was already 1, it's going to return false. So I keep looping. If log is 0, so no one has the log, then I put 1 in it, so it's my log now, and it's going to return. Unlocking, we just put 0 in the log, say it's unlocked now.
When is it returning false?
This
Can be stupid question, yeah.
This function returns false if it was not equal to this argument. So if it's not 0 in this case.
So the line number 15 executes when it's not logged, did you say?
Yeah, so line number 15 executes when it returns true.
When it returns true.
Yeah, so when it returns true, that means it was 0, and then puts a 1 in, it returns true, so I have the log now.
Okay, but the return is not really explicit in here, right?
How do you mean?
I mean that the true and false, like
I'm talking true and false that this function returns. Because I'm checking it with an if statement. My log just returns nothing, just void.
But it's the same if you just break, right?
Yeah, oh, God, also, yeah, of course. It's a nothing behind the loop. I could also do break. Doesn't matter. Exactly the same.
Okay, I see. Yeah.
So,
Okay.
if it doesn't have the log, I don't quite understand. Does it just wait there? Or does
Yeah, it's going to do a for loop and it's going to keep trying as fast as possible
it
to.
doesn't wait, it just goes around.
Yeah.
And around. Isn't that like.
Yeah, that's 100% CPU burn while I'm waiting for someone else to release the log. I'm not saying this is an efficient log. This is definitely not how you're supposed to implement it.
Oh,
But
okay, so the mutex doesn't do that.
no, mutex is a bit smarter. So here, let's test it. For m is, what did I call it? Mu. Here I'm gonna say m.log, m.unlog. Here as well, m.log, unlog. Okay, run. Oh.
You should click imports.
Yeah, oh yeah. And once in a while I should print format. And I think it was halfway. Ah, wait, now I see. Of course, I was executing this in here, and sorry, this needs to be, no, wait, time not second, and this one needs to be gone. So if I run it now, yeah, okay, that works. And it did how many? 5 million. So it's actually, well, yeah, it's slower than the atomic operation by itself, of course. But if I run this and I open my process monitor, it uses 100% CPU, so it uses 1 core. In macOS, it would use, if it uses 2 cores, it would be 200%. So it's really, it uses a lot of CPU, of course. One way we could easily fix that is, but that's kind of nasty, is if we can't get the log, then we sleep for a millisecond and try again. But that's also not really how mutex in Go works. In Go, the mutex itself, well, if you can't lock a mutex, it puts the thread into a sleeping state and it only gets unlocked, it gets running again if the mutex gets unlocked. Like there's a whole mechanism in there which makes it a lot more optimized that is impossible to write for us. One thing I could do is this, which would make it a bit better.
There isn't like
I think something like this.
eventing type. It sounds like it's blocking instead of eventing, right? Sure.
No, yeah, it's blocking. It's basically, so Go has a list of Go routines that are available to run, that need the CPU at any point in time. Just as your operating system has a list of threads that needs the CPU, that is active at some time. When you lock a mutex and it is already locked, your process or your Go routine gets taken out of that list of available Go routines to run and gets put onto like a sleeping list of Go routines that are sleeping. And then in the mutex, it keeps track like, oh, this Go routine is waiting for this mutex. And then the moment you unlock the mutex, it takes that Go routine and puts it back into the list of threads or list of Go routines that are runnable. So it's much smarter, of course. We can do something a little bit comparable, like I can do here, Go shit. So this way would already be a little bit faster. Now I'm saying if I can't lock the mutex, run another Go routine. So this actually tells the Go runtime that I don't want the CPU anymore, give it to someone else, and then of course I get the CPU again after a little bit of time, but this should probably be like, well, of course it's not gonna matter because I have a lot of cores, so Go max procs, yeah. So I tell Go to only use one processor, and now it did like 5.7 million. And if I remove this,
So I drifted away there. What does runtime Go shit do?
So if you're normally that infinite for loop would just be using CPU all the time.
Yeah.
This one says after one iteration of the for loop, I don't want the CPU anymore. Like, let someone else do some work.
Okay, gotcha. Sorry.
It's a very cool one.
But I don't think this is gonna have any influence because there is no one else to.
To be honest, I never write server level. I'm just like.
Actually, okay, this is interesting. So now I'm running it and it just doesn't print anything. Why doesn't it print anything? Because now my for loop here is taking, I give it only one CPU to run on. This for loop is taking that one CPU and it doesn't give it back to, like it doesn't say give anyone else any chance to run. So it doesn't, so it just keeps on running. And that other, and this other for loop where we're going to print, it doesn't get to run because that's, yeah.
I didn't think the mapping was that clean actually. Okay.
Yeah.
So a prop is like.
Yeah.
Is
like one thread basically in Go. Like if I
Go routine, right?
yeah, a Go. So normally a Go routine, it's not like one Go routine is one thread. Normally a lot of Go routines can run on the same thread.
So what's going on here?
So what's going on here?
So what do you say?
Go.
Multiple Go routines can run the same thread, so we still
Yeah.
have threads.
Yeah.
Still do?
Well,
Yeah,
the
yeah.
Go runtime in the background starts threads, as many as you want or many as it needs, but you don't really see that. And then it just takes those Go routines and lets, oh, that one on that thread, that one. So it's basically the same as your operating system and your CPU. Your CPU mine can run 8 things at the same time. Your operating system has a bunch of threads and it just puts those threads on the CPU. So Go actually is exactly the same type of scheduling mechanism, only now it runs multiple Go routines on threads. And what's the issue here? Because with your CPU, it's not a problem if you have this code. If you have multiple threads and you have one thread running 100% CPU, it will still schedule another thread on that same processor. With Go, it can't do that because it doesn't get, like, how would it know when to schedule the other Go routine? Normally it does that when normally it does that on function call boundaries. So when you call a function, the Go runtime at the same time checks like, oh, is there another Go routine that maybe wants to run? And at that point it switches like one Go routine to another between a single thread. But the atomic operation apparently doesn't have that check in it. So right now it doesn't have any code that tells it to look for another Go routine to run. While your processor, to put multiple threads on the same CPU, it uses something called an interrupt. So your processor gets interrupted by your CPU once in a while, and that just executes code that switches the thread. All really low-level stuff, maybe not even that important for Go. Let's just write a simple HTTP server first.
Yeah, let's do that.
I'll keep this code for now. Okay. We use the net HTTP package.
So basically, Atomic was taking up a whole processor by not allowing.
Sorry?
I was trying to summarize it from my brain. Atomic was basically taking up a whole processor.
Yeah, and it doesn't give any other Go routine a chance to get scheduled.
Is that a good thing then?
Well, normally you wouldn't write for loops like that. At least I hope not. Okay, to be honest, I never know exactly the function calls for the HTTP package from the top of my head, so I'm just going to quickly take this. So I want a handler, let's call it index.
This is my world. I'm just writing these things all day. Money. It'll pay me.
And this is just gonna do hello. It's gonna print hello as response, maybe v.header, I think. Oh.
And to be honest, I like boring. Because I understand it. Yeah, no one scares me.
Okay, so this just prints hello from, and then stops, and then I'm going to do like this, and I say so this is a very simple Go server. It basically says I have a function to handle slash, so this is just a path, HTTP path, and index handles slash, and then listen on port 8080, and that's it. So listen and serve will actually block until your server stops, but I'm not stopping my server here, so that runs forever. It's gonna call index every time I open it. So let's do this, go run test2.go. Okay, HTTP header has no field or method set. What was it? So that is actually a response writer. Response writer has header, which has add get. Header.set. Why is it giving this undefined type function? Or HTTP.header. What?
This is why I like
Okay. Line 8. No. Why is it? Oh, wait, I see. So header is actually function. So I'm here. Functions in Go are first class citizens, yeah. So actually a function can have all kinds of stuff. So now it's trying to get the set member of the header or whatever. I do this. It runs, doesn't print anything because I didn't ask it to. I go to localhost 8080, it says hello. So that works. Now let's try something else. I make another one. And I call this sleep. I import the time package. Or maybe I call it do work, whatever. And this one, time.sleep, time.second, or should I do time.minute? And I say work is handled by do work. So if you would write something like this in Node.js, for example, and I request the do work or the work path, then it's going to sleep for a minute. During that time, it can't really execute anything else normally then. In Node.js, maybe it does some stuff. Here, every HTTP request is executed in a different Go routine. So if I run this, and I do /work, that's fine, it's requesting. At the same time, I can do the index, it's fine, like, doesn't matter. I can also start a lot of work pages, all works fine because this one is executed in a different Go routine. So because every request is executed in a different Go routine, it doesn't matter like what I do in it, if I do I/O, if I do whatever, it will work.
Do you use any tooling to work out where time is being spent?
Sorry?
Do you have any experience of using tooling to work out which handlers are busy as opposed to other ones or something?
You mean like really which HTTP handlers, or which there's like tools which show which Go routine is running, for example, which Go routines are running?
I guess it's the more top level thing, isn't it?
If you want to know like which HTTP handler is doing a lot, then you have to write your own stuff for that usually.
Oh,
But
okay, I was just hoping the tools could just tell me where stuff
well,
is.
the tool will tell you if you have like a whole bunch of Go routines running, then the tools can tell you like this many Go routines are in this. Well, I can show actually, it's really easy. I know it's the pprof package, so I have to import this one. And then actually importing that one is kind of already enough. One thing about Go, if I run this now, it's going to tell me import and not used, because in Go importing something, not using it is like really a compiler error. But this package, importing this package already adds all kinds of stuff to my program, so I don't need to do anything with it. So if I do this, I import it and rename it to underscore, then it's not gonna complain. Oh, what the fuck did I do? So now I imported it, but didn't do anything with it. So now if I run this one, it's going to sleep. This one still works. Yeah. So now it added a bunch of stuff to my program automatically. I think it's added debug, pprof. Yeah. So it added an extra handler to my HTTP code. And this one, wait, let's do for while true, do curl this, done. Let that run for a little bit to start up some Go routines. Now if I look at this page, it says there are 6 Go routines running at the moment, and there is 2 Go routines which are busy with netpoll. So I think that's Go routines that are waiting for HTTP connections or something like that, because I see it's like, or I don't know, yeah, it's in the HTTP server package internal. I see there were 2 Go routines which were blocking on time, so on the time.sleep, which was my do work function. There's 1 Go routine waiting also somewhere, sees some TCP. So you can basically see what all the Go routines are doing. So if you have some issues or somewhere, then...
Have you refreshed that?
If I refresh this now, oh, there's other stuff running now. So you see also there's 1 Go routine which is executing this code now for the page it's generating. There's
What was your curl doing? Just...
No, I called it, yeah, I did just request, but it's... sorry.
It's blocking, isn't it?
Yeah, I need to do like this. I don't know if this is smart.
You want to run it background, is it?
Yeah.
You have AB.
I can do this. Yeah, maybe that's smarter, something like that. I don't think AB comes standard, so.
Maybe.
Apache benchmark.
Or like something like
What is...
AB minus N. AB space.
minus N.
Minus N number of requests minus N, and minus C will be the number of concurrency one.
how is it different? How is it different between AB and WRK?
I think WOK can do the same.
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 WOK is really
I
You
need...
have to do HTTP :// I guess so.
Is it Rust?
Yeah.
No.
What is it?
Make,
Why doesn't it tell me like what I'm missing?
an invalid URL it says. How is it
Oh,
invalid?
does it? Oh, there, invalid URL. Hoppa.
Yeah, that's all. Oh, it's pretty fast.
What?
Oh yeah, of course it's so fast, because I need to do work. Okay, so now when I refresh this,
You should see...
I should see loads, but I'm not seeing that. Why is that? Do 10 requests on 10 concurrents. Yeah, I'm thinking AB is doing something wrong then. We can find out.
Just open up lots of terminals and paste them.
No, just make it time.second. Oh, I make it sleep for a second instead, so now AB should, in theory, only run for 1 second.
Yes.
2 seconds. Now I got it. No, yeah, okay, now you see. Yeah, now 9. Huh?
You just wasn't refreshing it. Right?
Yeah, I think so. I don't know exactly. So now it did actually, you see here 9 Go routines running in the time. So this is useful to debug.
Is that the one you usually reach for people? Do you use like do you use Dell?
No, I'm really still a guy that does like this or a lot of printf and stuff like that for debugging.
Other than how do you debug CLI without using print?
There are tools for that, but I have never used those, to be honest. There's yeah, I think GDB you can also debug Go code. I think so, yeah.
There's a logger, right? There should be a logger. There should be a logger.
Yeah, also.
Debug label and default label.
Yeah, but the GDB also works. What I usually do, I can show quickly. I think.
GSH.
No.
Oh, yeah.
GSSH is this. Cut switch GSSH. We use Google Compute with our company, and this is basically SSH to a Google Compute instance. So it like tries to find the instance in all my projects, and then it just Google Cloud Compute SSH, and it adds my key, and it sets some flags, a whole bunch of that.
Was your experience good with G-Cloud, or were you?
Yes, really good. Much better than Amazon or Azure. Okay, we are online advertising. It's really,
your competitors' platform.
it's true, but it's like low latency. So our Go.
They didn't have servers in this region.
Not in this region, no, but in the US.
Do you know what low latency means?
Okay, low latency for us in the US, we have to respond like within a couple milliseconds. Our processes are handling like thousands of requests per second. Which all like have communication between servers and stuff. We run on Amazon as well, but on Google as well. With Amazon, you already have like 1, 2, 3, 4, like a couple milliseconds latency for packets between instances. With Google, that's like less than a millisecond.
So plus one to that. Yes, I have checked that.
The network traffic between instances on Google is much faster. Then you have the added benefit of we have servers that haven't been down in years because Google can migrate your machine, your instance from one hardware machine to another without any downtime. So with Azure, with Amazon, if they have maintenance, if the physical server that your instance is on is broken or is something wrong with it, your instance gets shut down, right?
You usually have to update your software and have downtime ordinarily. I'm not sure.
For some stuff, yeah.
You know, when people say like, "Oh, I can migrate my instance, and I never need to reboot it."
Yeah, no, okay, but the bigger advantage is if something goes wrong, if like there's a problem with the hardware or when you had the Spectre bug, stuff like that, they just migrate your machine to like an updated server.
It's easy for my puny Earth brain to understand that they've migrated the software off that hardware. Or, you have to reboot onto a new instance or something in AWS. Yeah,
that's easier to understand, but in this way, like with Amazon, you still have this ID of physical servers that your instance is running on, that there is something physical. With Google, you don't even care about what kind of physical stuff there is. You have a log with Google that shows like events for your machine. They actually migrate our machines between physical servers like multiple times a day. They actually do load balancing between their physical hardware for all the virtual machines that they have, and they keep moving and moving them because
sounds like they have a bigger abstraction than what even Amazon has, right?
Yeah, and much
bigger
better.
Sometimes not a good thing.
No, but in this case, it's really fast, so they're really fast and everything's good. And we use like the Google load balancer, so a global load balancer that automatically sends your traffic to the nearest virtual machine. Amazon has the same thing, but it's like much slower.
Things like foist Kubernetes on you and make everything slow.
We don't use Kubernetes.
Why
Use-
would Kubernetes make it slow? Have you had any experience with that?
I don't run it day to day because I hate the complexity that it drops down on you. But yeah, like I don't know, running images and updating software. It's slow compared to Lambda. Lambda, I do iterations with AWS Lambda and my Go functions. My iteration cycle is less than 5 seconds. 5 seconds I'm like, if it's a big project. It's sometimes way less than that.
There's a cloud function as well for Google, right?
Yeah.
You don't have to deploy anything.
Yeah, they have now as
I
well.
haven't used it, so I can't.
Anyway,
We use Kubernetes at production and it's serving us quite well.
So you're using what?
Kubernetes for our production system.
But you must admit that when you want to update your software stack, it must take 10 minutes, right?
Okay, there are microservices, right? So we
Yeah,
have if we have
But
our
usually you have to do some sort of atomic update with some microservices.
okay, so imagine we have some kind of code change. So you're talking about deployment, is it?
I'm talking about iterations. I mean,
Deployment.
It's
iterations.
a deployment. So it's imagine 10.1 is the current version. Now I'm deploying 10.2.
Yeah, how long
Right.
does that
It doesn't really matter because I have a rolling update. So it will take the container down and take the new container up.
take? Yeah, but how long does that
by
take?
few seconds actually.
A few seconds.
Yeah, it actually
Yeah,
depends
it
on
depends
how big your image is. If the pulling time of the image, if the image is really big, then the pulling time will be higher, and then you have more.
Just in my experience of just rolling out the image, just running the image, never mind the pull, is slow, especially when you have multiple instances and stuff.
to be honest, when we deploy new stuff, it takes a day. But that's just because I want it like that. So when I push like a new tag to Git, then it takes a day to deploy in all the servers. So if something goes wrong, then I notice it really easily.
Wow, who does the orchestration and
It's basically, okay, with Amazon you have, I can't remember, there's machines that can automatically get killed if there's not enough use of
auto-scaling? Auto-scaling is it?
No, oh, sorry, not auto-scaling. No, it's the machines that can be killed at any moment, but they're cheaper. Spot instances. Google has a similar thing, it's called preemptible instances, but with Google they always get killed after 24 hours. So even if they could run longer, if there's enough available, they still get killed after 24 hours. And we use that in an auto-scaling way. So for us, it automatically starts up those instances, how many we need. But they get killed after 24 hours and then new ones get started. And basically every time a new one starts, it pulls the latest release of our software and installs that and runs that. So if I deploy a new version, then it takes up to 24 hours to deploy everywhere, because within those 24 hours, all our machines will restart at some point.
I guess
So if something goes wrong, I notice it earlier because only some servers.
You can have what is launch configs like.
Yeah, you can have that as well.
So
I used it
do
as
you
well.
run Golang at your workplace?
Sorry?
Do you run Golang?
Yeah, we do.
Workplace?
Yeah.
Is it like a mainly Golang? Or
Yeah, it's only the backend stuff only Go. Yeah.
So it is advertising business. I'm guessing there's a lot of characters and you're using
Yeah.
this atomic thing. Or
Yeah.
you just
Yeah, a
use the
lot.
code
Yeah,
before
yeah.
You just dump out the code.
No,
and
and what I wanted to do today was present a bit more about optimizing Go code, like low-level stuff, but that might be a bit, if you don't know Go, it's too much. But anyway, to benchmark, or not benchmark Go, to see what is like using a lot of CPU, whatever, I use the perf command. I don't know, it's just a Linux command. If I run that, I can see exactly like how much CPU goes in where.
you're running perfectly with what? With what?
This is perf top.
You're perfing top.
Yeah, I'm perfing my whole, I'm doing top, so that this is the CPU usage of my whole system. So
I've never seen this program. If you use it?
it's a whole system. So basically I see that the most CPU goes in my kernel into some function called log text start. I don't even know what it is. then more, okay, so bidder is actually code that's written in Go, and apparently runtime.map_access uses a lot of code, so I have a lot of maps that are being accessed and whatever in our code, so apparently that is the most CPU. Then this is actually one of the HTTP handlers, so there's quite a lot of CPU going into the HTTP handler. IP tables is here as well. It allocates some memory once in a while. Here's some filtering matching code. So here I can see that if I wanted to optimize our Go code, I would probably look into this function here. So in the bidder filters, the match function.
So this is interesting. This is giving you your whole. This is Linux and Go and everything.
Yeah, everything. All binaries that are there that have.
Like
so here you have one. This is VDSO is I think a kernel driver for something.
But like, how can you get in such? Oh, it's telling you the symbols.
Yeah, this is the symbol. So here it couldn't look up a symbol.
Binaries are.
So Go binaries are
Includes the symbols.
includes the symbols.
Why
Yeah.
doesn't it do per record?
Sorry.
Per record instead of per
Can also, yeah.
What it'll show us perfect record. What is it?
You mean what? I can also record. Yeah, well, perf has all kinds of commands. Of course, I can record, but then I have to run a command, so I don't want to kill any process now. But yeah, I could do the same. But I always prefer to use top to see like really everything that's.
This one I have written one Go code. Like it's basically what it does. You can give it an input of a sitemap. Like imagine you have example.com, it has a sitemap. So you can throw a sitemap to it. It goes through the XML and find all the URLs inside of it, and then do an HTTP request to those and do the health check. So it's about basically you can tell it that go and do the health check on the sitemap for this site. So I basically wrote the code as a practice from my Golang, and then when I was running it works. But then after a few hours, I see it throws some kind of race condition problem, and I haven't been able to fix that.
Okay.
So I would assume that I probably want to run something like. Is that cool if you take a look at the code? It's a few lines of code.
You want to look now? Yeah, sure.
Yeah, I mean it's in the browser, but not there. If you go to the browser, GitHub, it's in GitHub. If you GitHub and look for Red Hat Raptor, search for GitHub. Yeah. And Red Hat. Red Hat.Raptor. Together, Red Hat.Raptor.
right?
Yeah, I'm sure. So, that doesn't work. I thought I. No.
No. GitHub.
Okay. This is much easier. Okay, Red Hat Raptor.
Yeah, this one. Yeah, and then the Go check sitemap is the first one. Yeah.
This is your project?
My personal, just doing some kind of.
Okay, I can look into this quickly.
I don't know why you chose this name, but.
Let's see what his code does. I'll try to explain while I read. So he imports a bunch of packages, like I see XML encoding, JSON encoding.
Yeah.
Okay, so first comment I would have, run go fmt to format your code, because I see your imports are not alphabetically sorted, so you probably didn't format your code automatically. Okay, we have an HTTP client with a 10-second timeout.
Wait, is that the way to do it? Isn't it like context nowadays?
Sorry?
I'm always confused by this in Golang. How do you make your HTTP client a timeout after 10 seconds?
Yeah, this is one way.
I thought you're supposed to use CTX or something like that.
It's also possible, the context, yeah, that's new, but this is also a good way to do it.
Oh, okay.
Check interval is like check every 2 seconds probably.
Yeah, okay.
And
then locations is okay, it's an XML. Then you have the statuses, which is a map from a string to an integer. And you have HTTP address, is you get the port environment.
Is that URL greater than lock me?
This is, okay, so in Go you have struct tags. So here's a structure with a member called logs, which is an array of strings. And then it has some extra metadata attached to it. And he's using the encoding XML package, which is an XML encoding package, and that XML encoding package looks into the metadata of the struct to find what it should do. And I don't know the exact syntax because I never used that XML, but I'm guessing this means that it's called log is the member, and it's probably in like a wrapped in a URL tag or something. Because you're parsing sitemap, so
Yeah,
github.com/sitemap.xml. That's GitHub.
You go to example.com/sitemap, for example. Yeah. It's HTTP for HTTPS. What? Hey, example.com should have sitemap.
Sitemap.xml, or is it sitemap. I don't know.
Sitemap. Actually, it's there. And if you go back to the repository and you go to the README, yeah, it's there. It's go down. Yeah, it's there. Sitemap.org. Sorry, sitemap.org.
Most people use sitemap.txt nowadays, I'd say.
I also have sitemap.
There you go.
Okay, so it's URL set log and then okay.
Yeah. So it has a log file inside of it. So if you
Okay, so let's see what else it does. You have a function getenv.
because I'm passing the
Okay, but there's an OS package, and the OS package has a function called getenv.
Usually using OS there.
Yeah, wait. And the OS package has a function called getenv with a key and returns the value. So
much simpler.
what you're doing here, os.lookupEnv key, and then it returns the value or not.
Well, that's an easy mistake to make.
Yeah, you need to know like which functions there are.
So that
let's see. So
it doesn't exist, I guess.
let's see. Yeah, exactly. So getenv.
It's not being set.
Getenv returns an empty string if it's not set, and lookupenv returns.
This one is quite elegant.
So actually, this one just does the syscall.getenv, and lookupenv does and ignores the key if it ignores the second return value if it was set or not. And this.
So I wouldn't need to check the errors if I use getenv, right?
Yeah. Okay, so you have a function getSitemap, which has a sitemap URL string as argument and returns an array of bytes. It does a get on that URL, then if there's an error, it just does log.fatal, which you don't even need os.exit, because log.fatal doesn't os.exit.
Okay.
I can show log. So that's here you do log.fatal. What does log.fatal do? Log.fatal does a print to std and does an os.exit. So here it's useful to look into the actual Go code once in a while. Okay, so then defer statement. We didn't even. I'll show you quickly what a defer statement does, because that's really unique to Go. So I have a function foo. That does some stuff, time.sleep, time.second, and then defer. If you guys want to get some drink as well, then we can have a small break.
Yes.
Is it follow it? Can you guys follow it? Yeah? It's good enough, or should I explain more, or?
Yeah, I have a few questions. Actually, I see that there is no classes in Go.
There's structs in Go, not classes, no. So there's structs, so what I had before, that's type A, for example, is a struct, and then it has members like I integer, and you can do functions, a foo or bar. So basically this is what a class is as well, only we call it in Go, we call it a struct, so it has a member and it has method, so this has a bar method on it. But yeah, not really a class, like you sort of have inheritance and stuff as well, but it's a bit much to explain now maybe.
Actually, you didn't explain last time why you used the pointer.
Oh yeah, that's easy. Okay. First, I'll explain defer. So defer wants a function as argument, but it's going to execute that function when the outer scope exits. So this function foo, if I call this function is going to defer the print line, so it's not actually going to print anything in the beginning. Then it's going to sleep. After the sleep, the function returns, and then it's going to execute this. So if I do this, it sleeps for a second.
It's the same as like the bash trap, isn't it? Trap. And the trackpadding works on sig instantly.
Yeah, no, it's different. So if I do multiple defer statements, I do here 1 and here 2, this is going to execute this, then it's going to execute at the end of the scope, so at the end of the function, it's going to execute the defer statement in reverse order. So this is going to print 2, 1.
Oh, I didn't know that.
Oh, this one I didn't know.
The useful stuff for this is, for example, normally you would have stuff like, if you want to open a file, you would do f error, or let's ignore the error, is os.open some file.txt, and then I would write defer f.close. So I want to close my file, but I won't want to close it right now. I want to do stuff with it first. But, so here do I f.read, whatever. So what this enables me is to have my open and my close statement at the same place. If I have really complicated logic in my program, like where if blah blah blah, then and then maybe later I have then I want to return, and maybe later I have some other code where if whatever I also return. In other languages, you would have to do this. You would have to write like, oh, I want to close my file. Here is where I return. Here is where I return. Here is where I return. But in Go, that's not needed. In Go, you actually say here, like where you open the file, you also close it with a defer. And then, and then I don't need any of these statements. So if it returns here, still gonna execute this. Returns here, still, it's always gonna execute this code. Doesn't matter where I return. And it does the defers the close in the opposite direction. So maybe I want to do like os.create. Maybe I want to create that file and or no, what's a good example? No, I'm thinking what's a good example to show if you want.
Maybe if you open up several files.
Yeah, if you want to open up several files and you want to close them in the same order, or if you, let's see, I don't know, but it's useful that it's in the opposite direction of how you execute them. Anyway, that's what defer does. So in your code here you had a defer, so what he does here is he fetches the HTTP, the page, and then he closes the body in a defer. So if you close the body of an HTTP request, it will close the connection or may allow you to reuse the connection. Then you read also here, if you wouldn't defer it, you would have to write this close in here and here. So this is much easier like this. Okay, you're going to read the whole body of the response, and then if there's an error, you do that again, and then you return that response. Okay. Check sitemap goes for all the URLs in there. It's going to sleep, check interval that time seconds. Then it's going to fetch the get HTTP status is just a get request where you return the status code. Okay. One minor thing is here you also need to close the body. So right now if this get request returns a body and you don't read that body, then Go is not going to reuse the connection because there's still a body waiting on the line. It's still body. So if this is not going to do any like keep alive connections that are going to be reused. Here it's just going to do the request. You're not reading the body.
Yeah.
So at some point the connection gets terminated because of a timeout or whatever.
Yeah, but I'm not trying to read the body here because this one is actually checking the status. So all I need is the status only, whether it's the 200 or.
Yeah, but now you're opening a connection to request the status. Maybe the server supports keep alive, maybe not. Doesn't matter right now because you just keep that connection open, not doing anything with it. Okay. Next time you're fetching, it's going to open another connection again. Maybe that server supports keep alive and you can just keep the same connection, TCP connection open.
Okay, I see what you're saying. So it's like connection, I could basically get some benefit from here by reusing the same connection, right?
Yeah, and that's enabled by if you just read the body. Because if you read the whole body, then the connection is clean again and can be reused for another request.
Okay, so I can read the body and just dump it in.
Yeah, just discard it, just don't do anything.
Understood.
Actually, I didn't quite understand. You read the body, you discard it, and then you can do something.
The idea is, right now, you're not reading the body, so the body is still somewhere in the buffer or whatever your OS is keeping that. It's still somewhere. There's still a body waiting. You can't reuse that connection at the moment because if you send another request, then yeah, it blocks the whole connection because you're still reading from it. Yeah, so you need to read the whole body first, and then after you read the whole body, then the Go library is like, okay, this connection doesn't have any outstanding requests, there's no data incoming anymore, I can reuse it for something else.
That's a bit tricky. How are you supposed to know that there's a part of the request, i.e. the body, which is just hanging around in this case? From API level, I don't know.
You try reading it.
Try to read the API. Damn it.
No, and I mean you try in this, yeah, in this case you need to know that you need to do that, but normally you would just try reading the body and see if...
Sorry, it's garbage collected, right?
Yeah, but the connection is still open, so there it isn't getting garbage collected.
So does this also mean that if I read the body, then the body content is discarded already? I cannot call the same function again. If I read the body, and then if I call the function again to read the body. If this function returns and you don't have this reference to this rest variable anymore, then you can't read that body anymore because you don't have any access to it anymore. That's lost somewhere. Then it's the connection is still open in Go somewhere, but that's, yeah, at some point it closes the connection, yeah. But I think what he's saying that since I'm returning from this function, does Go not supposed to close the function anyway?
Yeah, it will. Yeah, at some point it will, but it will close the connection because it will think like
it will be basically done at some point.
It will think there's an error. It will think there's something wrong because there was still data that you needed to read.
Okay, so rule of thumb is that if you're making an HTTP request, read the body.
Yeah, always read the body.
Or at least close it. I mean, in this case.
But in this case, if you're going to close it without reading the body, and that's a Go thing, I would say, if you close it without reading the body, it's going to close the connection because it thinks like, oh, there's still data on it, but you want to close it, then I probably shouldn't use it as a keep alive connection.
Okay.
But in theory, Go could also say like, oh, if you want to close the connection, there's still data left, then I read it for you and discard it. But they chose not to do that. Sorry?
I thought it's optional to read the body. You can just read the header, you don't need to read the body. Right?
No, if you don't read the body, then it's not going to use it as a keep alive connection.
That reminds me of something. I was actually trying to make a head request instead of a GET request. Then I found out that HTTP package doesn't really have a.
It doesn't have GET.
I couldn't find GET request.
Client. Yeah, client has head. But yeah, no, head. You can use head.
You sound very experienced if you know the API this well. You must use this every day, right?
5 years.
Me, yeah. Okay, so if there is an error,
There's so many nuances to some APIs.
yeah. If there's an error, you continue. Otherwise, you say like this URL has this status.
So the data structure where I'm just.
Yeah, I saw you have the map here.
Yeah.
So you keep this. So you say this URL has this status, and then you print the URL and the status code.
Right.
This function we already covered. This does get statuses, which does it marshals the map into some bytes, and then you write that out. So what this actually does, this function, it takes this URL statuses was a map or a hash table or whatever you want to call it. In Go it's called a map, and Go has really easy stuff for JSON, so it just turns that map into JSON. The easiest way is to go to the example and then do you using Marshall. Where is Marshall?
Isn't it true to say that encoder would be faster because it's streaming?
No, this is all.
Because Marshall would do the whole thing.
Yeah, okay, so what he has here, I quickly show. So you have a map like this.
Oh, you can, I think.
You can, but you need to manually do that. Actually, does that automatically for you.
So you have something like this.
Marshall, by the way, I don't understand it.
Marshall is just another name for.
Yeah, it's another word for encoding. Yeah.
Serializing.
Serializing, yeah.
Several words for the same thing.
Sounds so fancy.
Okay, so
Yeah, I'm marshalling it. Okay, I'm not encoding, I'm marshalling it.
okay, so what he's basically doing here, you have that JSON.marshal function, which has, it doesn't matter what you give it as input, and it outputs like JSON. So this generates, I have it here, like the Go map from string to int, which is like this. Or maybe I should do like really, like 404, whatever. And it basically makes the JSON out of it, valid JSON always. So Go is really easy with working with JSON. So what you have here is, this is an HTTP handler, I can see by these arguments. You marshal that statuses and you return that as a JSON response. That looks good. Then you have the sitemap URLs. You have it's empty. So here you actually do use getter. And then you get,
Do the get sitemap so that
oh yeah, you get the sitemap from this one URL.
right.
Then you, with the XML package, you unmarshal that sitemap into URLs. URLs was this thing, yeah. Then you define the handler and you do go check sitemaps.
Right. So if you run this code, I mean, there's a Docker container you can just run it. So what it does is it shows the statuses and it also publishes the statuses in 3000, localhost 3000. So what happens is I sometimes get a rest condition where it says that something was trying to write, I'm doing probably the same thing what you showed today. So.
Yeah, okay, so I can show you now why. So you run this in
So the idea
a Go.
is that
Yeah, so you run this in a Go routine. But like I said, all HTTP requests are also run in different Go routines each time. So here you have check sitemaps, and check sitemaps writes to this map. This map is a global variable. So here it writes to this map.
Yeah.
But you also have this HTTP statuses function which reads from it.
Yes.
So to improve this code, you would have to do, wait,
Yes.
can I?
You understand it?
I thought you were going to say that there's something wrong with that Go func. Why doesn't he just go?
So that we sync.
Shouldn't it be like a for loop and then in the for loop you go check something?
No, this the code itself is okay. So
Okay.
so
Okay, so we have the mutex.
I'm adding a mutex and yeah, exactly what I just said, and then here mu.log.
And then you want to block the reading and writing.
Here.
Okay.
So everywhere where I use that global variable, I'm going to do. And what we can also do with mutexes, what you do a lot of times is actually this. You defer the unlock. So you just at the start of your function, you lock your mutex that you need for the rest of the function, and you defer the unlock. And the advantage of this is also defer also if there's a panic, if something goes like completely wrong, like a divide by 0 or stuff like that, defer still executes. So if I do,
that's quite a nice way of doing it, because you're not so pedantic, are you?
yeah, I can show that here. So I defer fmt.println, and then I call a. So if I run this, of course that's gonna print foo. But if I do a is 1, b is 0, a is a divided by b. It's still gonna print foo, and then it's gonna panic. While if I do this behind here, of course, that's not going to print anything. That's going to stop my execution here. The advantage of that is if I do sync here. Yeah, and now why that's important. I have a mutex. I lock it here. I unlock it here. If I run this, yeah, that's of course going to crash again, but in this case the mutex gets locked, but it doesn't get unlocked. And because this Go routine is the only one that can unlock it, it's basically, it's forever locked, so no one else, everyone else that tries to lock it is gonna just hang, so it completely hangs your program. Well, if I do it here, then it will always get unlocked, even if there's an error or whatever happening.
I feel like writing lots of code to make sure that there's patterns everywhere.
Yeah.
This is lifesaver.
Yeah. And the important note on that is that, of course, this panic crashes my whole program, but you can catch panics. So if I do a func B, which calls A, but I don't want my B to crash, because right now, if I run it, of course, it's going to crash again. In Go, there's something called recover, so, and that's together with defer, so I can defer, for example, an anonymous function, in which I can do, if error is recover, if it's different than nil, then, for example, I don't know.
Like a finally handler?
It's like yeah, like, or more like catch. Now it's more, so defer is like finally, like exactly the same as finally in Java, and recover in a defer is like catch, sort of. So if I run this, now no program is, oh, sorry, my program is not going to crash, my program. Is going to say there was an error.
But then
of course,
you don't have the context anymore, right?
Of course, this here, this not printed, but if I have a statement here, this is just going to print. Of course, this one is not going to print because A crashes, so we go to the defer here, but it's going to recover from the defer, so this one returns normally, and this is going to be executed.
How do you do like the JavaScript equivalent of catch E? You know, how do you catch the error itself?
Yeah, here I have the error here itself, so I can also print the error if you want. Here.
Okay.
So the error was, yeah, runtime error. So now printed actually gets printed. Well, if I don't recover in my defer, then this one panics, crashes, so this one is not printed, but it goes all the way back to, so this is also not being printed. Oh.
Do you use this pattern a lot in your work, I guess?
Yeah. So now it's just gonna print. So wait.
What if in A, right, you lock twice and you defer twice?
You can't lock anything twice.
No, I mean you lock, defer, unlock, and then lock, defer, unlock.
If you mean like this?
Yeah, and then you.
Okay, so now here I lock it. I defer the unlock, so I don't actually unlock it. Here I try to lock it again, but it's already locked, so this is gonna hang forever. If I run this, it's gonna say run out of time or whatever. Yeah, here it says all Go routines are asleep, deadlock.
But sometimes you have to do like the operation on the second lock.
If there's a different lock, you can do that, yeah. If I have a mu2.
Also, you can't reuse the same lock for that.
No, if a lock you can only lock once.
I know you lock once and then you unlock it and then you lock it another time.
Yeah, you can, but then you don't need, then you can't use defer, then you need a normal unlock.
But
yeah.
sometimes you have to do it inside the first lock and unlock. Do something inside the first lock and unlock and second start.
Yeah, then you would, yeah, two functions maybe you would use then.
You use functions.
Or it was something that you can also kind of do. So if I have here, for example, I is an integer 0, I can say, it's a bit ugly, but I can make an anonymous function to make a different scope.
Oh, so the defer is about the scoping.
So if I do this, yeah, defer is about scoping. Yeah, whatever, I remove all of this for a second. So now I create a new scope here and I defer the unlock in here, so now it's gonna unlock here as well. So basically defer is linked to the scope, so this is just gonna print 1. Yeah, 1. So now you can do it like that. You can make an anonymous function to just make a new scope, and that anonymous function can still use everything from the outer scopes, of course.
But you cannot scope it like just with curly braces.
No. No, if I do this.
Yeah.
So its scope is really like a function scope. Yeah. For loop is also not a new scope. It's really a function level.
Really, you can have a curly braces with nothing in function. Is it to a sequence error in Go?
No, because actually if I do here a variable j is 0 and I print here I plus j, this is going to be an error because the scope of the variable, scoping of variables is different from scoping of defer. Defer is really scoped on the function level and variable scope. It doesn't.
How nested it is.
Yeah, it has nothing to do with like variable scoping.
Oh, can we get back to his code? Were you just finishing it? You just give an example?
Okay, so.
Yeah, so I fixed it here by introducing.
So how do we know it's fixed? Don't you want to change strong?
Do I what? Yeah, I don't have. I don't have Docker on my laptop, to be honest. So.
Okay. Can you send a pull request? I'll show.
Yeah, let me think of this.
Oh, can you just go to the bottom? I just had a. So that's the way to do it. For some reason, I thought that. Oh, it blocks the dissonance. So,
yeah.
oh, okay.
But I would do some things different. So one issue I would have with this is you have here this for loop to check all those requests. Yeah, okay, you set a timeout of 10 seconds, so okay, maybe less of an issue. I would write the code like this, and I don't know if you want me to do a pull request for just this or it might change as well.
I'd be more than happy because I want to learn what you did.
Okay, so
do it in
run.
Can you
With,
commit that?
okay, well, I'm gonna do it different.
Just commit what you have, and then do another commit.
Yeah, okay. Fix deadlock. No,
Is that a picture of you? You're so different.
what?
Yeah, it looks different.
Yeah, create pull requests. Create pull requests. Okay.
I don't really like the sleeping of the 10-second, like it looks quite synchronous, like you have a for loop and then you sleep and so on.
Yeah. Okay. I would do it like this.
I think you should edit your own branch because there's
there's a couple ways to do it, but maybe this is nicer.
Merge it and I'll run it right now.
Sorry?
I'll merge it and run it on my machine right now.
Hopefully I didn't make an error. Okay, so I would do it like this and do like a Go routine for every URL, a different Go routine. So now this one gets only one URL as argument.
Probably if you don't use in Go or something.
String. Sorry?
I'm hooked to the Golang editing environment, you know, the Go format writing all the time.
Yeah, but
you're doing stuff in your brain. You got a strong game, man. Your typing skills are excellent.
For sure.
Typing is so good, right?
Yeah.
What's wrong with me?
you know why? Because I do all my coding in Vim without any plugins or anything. So I don't even.
Go. I'm like tap.
No. But
Vim Go is awesome, man. It's like makes Vim like.
And
awesome.
I really like here in this, if whatever I do, I save and it formats automatically everything. I usually write like really like nasty indentated code, whatever, and I know I have Vimgo or something installed in it. Yeah.
So on left right, then you do the format, Go format on left right.
Yeah.
You edit your MyVim.
I can't remember.
Do you use NeoVim or Vim?
Vim, really Vim.
Why don't you use NeoVim? Just checking.
I don't know. I also know some guys who use like all the shortcuts in Vim as well to like do all kinds of weird stuff, but I just use the arrow keys and I always think like programming is mostly about thinking what you're going to write and doing it, and then writing it takes a little bit time, but I don't need all those shortcuts and stuff, the time it takes for...
That hard code is you got syntax highlighting, like a
Yeah. No, the time it takes for me to like move my cursor, I can already think a little bit about what might happening or whatever, and I don't need a fancy editor with like tab completion, stuff like that.
I'm fixing people's code. I don't know if you think about that.
So I think I would write it like this.
Why did you put a sleep in there?
Because you don't want to keep hammering the server to check if it's up. You want to check and then wait a bit and then check again.
I thought this one checks.
I thought the idea with this program is to just check a whole bunch of sites.
But he wants to keep checking them. He wants to fetch the sitemap once and then the URLs in it just keep on checking them if they're up or down.
Oh, what was his cycle before? Like, keep checking them every 10 seconds or something?
It checks every check interval second, so that's
Oh yeah,
every 2 seconds, yeah.
So he's basically...
But, okay, so what I changed now, before you had this loop, you had one go routine which was checking it and then sleeping. So it was basically fetching one URL, sleeping for 2 seconds, fetching a next URL, sleeping for 2 seconds. So if you have 1,000 URLs in there, you're gonna check every URL every 2,000 seconds instead of every 2 seconds. I'm guessing you meant to do it every 2 seconds. So what I do now is I start a go down. So for every URL, I start a go routine, separate go routine to check it. So then if you have, and then in that go routine, I sleep for that time and check it. So then if you have 1,000 URLs in your sitemap, it's gonna spawn 1,000 go routines, and each of them is going to take every 2 seconds, check their URL.
True, but then is it not banging the server like with 1,000 requests per second, for example?
Yeah, but that's how you want it. Then but with this method, I can say, okay, check them every, I don't know, every 10 seconds. And it still doesn't matter how many URLs I have in my sitemap, it still checks them every 10 seconds. And with your method, depending on how many URLs I have in my sitemap, I would request them more often or not.
Yeah, this one is quite good, but then the problem is that if I'm hitting the production server with like 1,000, imagine I have 1,000 URLs and it's going to hit 1,000, like every 10 seconds, it's 1,000 requests going in.
Yeah.
And the server is like,
no, that's true.
So then we can do like something like batch processing, like it will take like, I can say like, if you send requests, 20 requests at one shot.
No, I don't know, are all the requests to the same server, or is it like different domains and stuff? You could... So in the sitemap, it's all the same.
Same server. Yeah, because one sitemap is actually for one server. Like imagine example.com/sitemap.xml. It actually contains all the sitemap for that server only.
Yeah. Also, you use actual sitemaps. I thought you just used sitemap as some.
No, it's actually.
So
you can actually.
Okay, so you're not really interested if the server goes down, but if the actual specific URL goes. Or not, or
so they actually get a notification using another service.
Okay. But yeah, I would then say then maybe your method was better, where you just if you want to send one request to the server every 2 seconds, then your method is better.
You would have to wait a long time.
Yeah, that's also bad. It's like, how do we do this? Like 20 requests at one shot, and then again 20 requests.
Yeah, how do you limit the number of go? Like
You want to do 20 and then
20, and then it's like a worker. Like you have a.
Yeah. Okay.
I think you do this in a.
There's multiple ways to do it. Yeah. Okay. So if you want to do batches, then I would say do it like this. We make a batch, and we're not.
Or you do a slice maybe of the.
We're going to for infinite loop. Batch is URL.logs. Let me think. So batch is going to be an array of strings. I'm going to make. Wait, let's keep my code together. Batch size, so you want 20, so I'm going to check if the length of this thing is bigger than 20. If it is, then I'm going to batch is, oh wait, batch size.
So batch size is 20.
can't believe you're going back to Amsterdam, Eric. This is bad news for us.
This is so bad, guys. I don't accept
Someone hired him. It's good.
Yeah.
And then, okay, check the patch, and
Your wife is going to hate it. You're going to come back.
and then
What's wrong with that?
Okay, I'm going to have salad with you. Okay, I'll take that off.
I don't know. Let's. I'm putting this in a different variable.
So, what is it doing?
Yeah, wait
Left
1
side
second.
He's going to slice it up.
Yeah,
okay.
left.
And he's going to do a for loop.
Left.
But actually, is also not.
That's a complicated for loop here. You could do
Yeah, and I'm writing it wrong now. I think you want to request 20 at the same time, and then wait a while, and then 20 at the same time again.
So we can do 20 at the
Okay,
same
then I'm doing
time,
it wrong.
Then wait for all to be resolved.
Yeah.
And then when all done.
Okay, yeah. Then we use the wait group approach, what
Yeah,
you said.
wait group, yeah.
Okay, so in that case, I'm going to remove this whole for loop and this sleep.
So it's kind of like it's producer and consumer.
Yeah. Okay, so we're going to.
I work for Intelligent. I made up my Intelligent Money. The company is Intelligent Money SDNDHD. It's called iMoney.my. They do some dodgy. Yeah, it's a little bit dodgy, but it's cool.
I'm thinking.
It's
I'm thinking what's good. Do another for loop.
We're actually number 1 in Malaysia. Because
I like the people behind me first.
yeah, they're cool.
What was it? URLs dot box. Okay, so I do it like this. Then this one, yeah. So we start with sleeping, and then.
Okay, so.
Wait, let me see if this works for us.
URLs, the logs, for each, so we have a timer steps. We have a wait group.
Those wait groups work.
Yeah, wait. Let me write the code first, see if I can get it working.
Wait group is to, if there are 20, is to tell that if all the Go routines are done, then continue, and otherwise log. Otherwise, don't continue if all non routines.
So you need to check that all.
Yeah, so wait group will take a parameter. Yeah, so it's like this, yeah.
Oh yes, add 20, yes.
So it's I add 20 to it, and every time one is done, I say done, and then here we do wait.
Oh yeah, for each, yeah.
Wait.
Yeah, it's count that 20 times.
What happens if there isn't 20 then?
Yeah, that's what I'm doing now. So if I is bigger or equal to the length of left, then break out of it, and we're done here. And then here we do like this actually, but no, like this, sorry. But now we also have to check if len left is 0, then no, wait, if len left is less than 20, yeah, then left, then we restart, and else, think something like this. So yeah. So basically we have an infinite for loop, then we make a new slice out of all the URLs. We have a wait group, we start 20 Go routines. Each of them will say to the wait group if they're done or not, when they're done. Then we wait until all 20 are done. When all 20 are done, we sleep.
Why do we sleep?
Yeah, you wanted to wait in between the 20 batches.
Yeah.
Then we say if the number of items in that left slice is less than 20, then apparently we're done, so we start from the beginning again, and otherwise we just make the slice, well, the next 20. So we skip the 20. Yeah, this is like, I don't know, Python also has syntax like this. So this basically says, take the first 20 items off the list and then take the
I
rest.
just want to understand that if you have less than 20, so there's going to be like some URLs there, and then you set it to you basically the end of the list, right?
Yeah.
And then you say if it's less than 20,
Start over again.
start over again.
Yeah,
But
because
that means there's some URLs that don't get done, right? No.
no, because this is after I did those first 20. So I'm trying to process 20 of them. If there's less than 20 left, I already did those. Then I just start at the beginning again.
If they're less than 20, you've already done them.
Yeah, because here I'm trying to do like it is a slice. If let's say it only
So you're
contains.
basically accounting for when you break or something. No, wait.
Yeah, basically also.
Shouldn't you do?
So here I'm just.
Maybe you should do that. Okay, it probably works.
Okay, there's one reason why this is not gonna work, because there's one mistake in here. But yeah, so I usually take the first 21 from that slice and I process those. So if there was less than 20 in there, but I already processed at least 20 of them, so I processed everything. This is actually going to request the 20th URL 20 times, the 40th URL 20 times. Why? Because I execute this in a Go routine. It's also a race condition. Here I'm reading I, and here I'm writing to I at the same time. So that's a mistake. So that's why by the time this Go routine is started, and it's going to read I, this for loop will already be done, and I will be equal to 20. So what I need to do here is add I as argument to my anonymous function here. So now I read I in the same Go routine as where the for loop is in, but I have it here as argument, and then it's fine. That's a mistake that a lot of people make.
Yeah, because they don't realize that they're actually going.
I can show that. For I is 0, I is less than 20, I plus plus. I start a Go routine, I print in there. Oh, I don't know what happened here. I print I in the Go routine. Let's make sure it doesn't stop before it gets time to print. Oh. This is gonna print 20 times. Ah, error, I didn't even know that. It runs govet these days as well, so it actually gives me a sort of a warning. So what I said, you have to make I an argument, and then it's fine, and then it's actually gonna print 1, 2, 3, 4, 5, 6, 7, 8. Yeah, also in order, that's also nice. It doesn't have to be in order, it could print them in any random order in theory.
But what way if you want to do it in batch? You do it like 20 at a time.
Sorry? This is a batch now, like I wrote it
You're
here.
going to do 20 at a time?
Yeah, it does 20 at a time now.
No, I mean after you do 20 at a time, what if 10 completed and 10 not completed, you still complete.
Then it's going to the next batch, is going to be those 10 that are left, and then it's starting again.
But how do you confirm that? Can you make it like 20 at a time?
Always 20. So if there's 30 in the whole batch, then it does 20, then the first 10, the last 10 and the first 10 together, and then you want it like that, or?
No, I mean like, if 5 completed, you will still wait for the other 15, right?
Yeah.
But in this case, after 5 completed, you take in another 5. It's always 20.
Okay, like that. Yeah, that can be done. I'll make a simple example, not here. I'll just write a really simple example for that.
It'd be great if you submit that code. I'd like to
Yeah.
learn from it.
Yeah, before you forget to,
Okay. I don't know if it's this guy is gonna compile and whatever.
I've never seen anyone do this. This is very great.
Yeah.
So take my pull request. I just edited it.
Okay.
I rely heavily on tools.
I'll create a pull request for this.
Thanks.
And then I'll write what you say. Oh, so you mean always have 20 outstanding requests?
Yes, right now.
That's also quite easy.
Actually, a sitemap is a great example for doing these things, isn't it?
So in that case, I'm going to move this out here again, and I'm going to do this.
So if I merge it now,
And then,
it's stop working.
no, maybe merge conflict when I make a pull request.
Yeah, just take that pull.
So actually, I'm going to create a Go routine for every URL. But maybe that's not safe. Huh.
How do we save or not?
No, I'm thinking, okay, the way I was first thinking to do it, but I realize now it's wrong, is do it like this. So here, you get this.
It's doing one by one still.
Yeah, now, and so now it's doing them all at the same time, but you want 20 as max, so I import,
Is it because I have a per second, my reader is rendering one by one, maybe because of the, well, no, let me check. So, I go here, I'm supposed to see 20 at a time now. No, it's one by one, my bad. No, it's the master, sorry, my bad. So,
Streaming on this really shitty surface.
so you want 20 outstanding, but still in order.
I can actually go here, quickly copy the code from his.
Okay, I know how.
Yeah, you can do it here. Yeah, sure. Yeah.
You guys get much of that?
Yes, I really enjoy the way how
Yeah, but these are yeah. I thought Eric did an amazing job.
That's me. Not like this.
That's actually a good example of this, because we can use channels now. Fun. Is this correct? Yep. Okay.
Hopefully you won't be too daunted. I mean, I used to go every day, but I very rarely do this sort of stuff. You only do this sort of hardcore stuff when you're trying to make things go really fast. And as I mentioned, making stuff going really fast is like premature ejaculation. You don't really need it. That's my favorite.
Yeah. Okay, I fixed it the way you wanted.
Wow.
So, okay.
Wow.
We're going to use a channel. Something new. A channel in Go. I wrote it. A channel in Go is basically also a synchronizing primitive.
Channel now.
Yeah, so a channel is something that you can put something in, like a value or whatever, and someone else can read out of the channel. And that's all like locked and whatever, so you don't have to do any mutex or whatever. So here I make a channel of strings. So I'm going to put strings in the channel. Then I do, okay, this is wrong, of course. I have to put this in a Go routine, otherwise this is going to block everything forever. Okay, so I start in a different Go routine. I'm going to loop forever. Then I'm going to loop over all the URLs, all the strings, and I'm going to put them in the channel. This channel, I didn't give it any size, so the first time I try to put something into it, it's just gonna block until someone reads that. In Go, I could also do like 10, for example, then it gets to put 10 values in there, and then you have to wait again until someone reads it. This I make unblocked. Then I start 20 workers, and I give that channel as argument. So here we have someone who's constantly putting the next URL in the channel, and from the at the end it starts at the beginning again and tries to constantly put all the URLs in the channel. My 20 workers have the channel as argument, string channel. This one is just going to read from the channel, execute all the stuff it needs to do, and read the next URL from the channel. So now we have one process constantly feeding the next URL, and we have 20 workers which each just fetch a URL from the channel, process it, fetch the next URL from the channel, process it, and then you have 20 workers at the same time just doing their work. Is that clear? Is that...
The thing, like this make thing, it can accept it. That's the thing with Golang.
Yeah, that's a Go thing. So a channel you have to make, or if you have a map, for example.
I find it interesting that it has an optional.
Yeah, optional buffer size as well.
How do you do that in a normal Go function? You can't. It's only make is an exception or something.
How do you mean? That the argument is optional.
Yeah.
Yeah, that's an exception for make. Yeah.
And then going back to the keeper life thing. So each worker is doing its thing.
Yeah. So
and it's making connection with the same server. Is it,
yeah, if it's the same servers, then yeah.
It will keep alive. How do we know it's actually keeping alive?
Right now, because it's doing 20 requests at the same time, it's probably going to open 20 connections, and then for the next request reuse those connections again. But because they're all in parallel, those 20, it's probably can't reuse those connections. Maybe if like the first one is really fast that the last one can reuse it, but...
So it's all like behind the scenes stuff, I guess.
Yeah, yeah.
But I guess if you're a little bit more pedantic, you would have a look exactly what it's doing.
Yeah.
It would make sense. How would you look at what it's doing?
What I do, of course, we have a lot of services which talk HTTP to each other as well. I use not TCP dump. What is it? LSOff? Yeah, that's a Linux command. I don't know if you're familiar with that. So I actually look at just the open file descriptors, like I can show again. Am I still connected to that server?
What are you looking for?
So I have here my bidder process, sudo lsoff -p. So that has like a whole bunch of established connections to some other local service.
How long
So,
can you tell they've been around for?
so what I usually do, and maybe it's ugly, I don't know. So I look at the established connections. Okay, then I sort them. Okay, maybe I only want the established connections or the connections to that one service, not everything. So I want basically this. Okay, I sort them, and then I don't know, it has a lot of them now and I have a small monitor, but maybe like something like this.
The channel one.
Okay.
It's
Yeah,
like a worker.
Yeah, so the channel one does 20 workers that in parallel all at the same time start fetching those requests. But the previous one was either all of them at the same time or it was all of the one by one. So this one is like, this is with Go, how with like channel like this is how you, if you have something with multiple workers. And here I could also say like have 100 workers or 1 worker or whatever. So it makes it really simple to spread out the jobs that I have to do, the work that I have to do over multiple workers.
But does this, like, the 20 workers do the first URL?
What?
First time, or they do the first code routine do the first URL, second code routine do the second?
No, this is here I put the URLs one by one in the channel, so I start 20 workers. The first worker that gets CPU time will fetch the first URL, the second worker will fetch the second URL, etc, etc. No, they're not both fetching the first one, because I put it in the channel, and if I read from a channel, only one worker will get the value from the channel. A channel is synchronized, so you put something in, you get something out, and it's never that multiple people get the same thing out. Yeah, the worker is another Go routine, yeah.
Yeah. Yeah.
1 second. To check the keep alive connections, I usually do this. So, you know, watch just runs the commands, and -d prints the difference, so it highlights the difference. I run it every second. So basically, I run. It says in the top.
So this is how
Can you control C? Can you control?
That's still on the top there, the command.
Oh yeah, but I don't see the watch -d.
Oh yeah.
this. I'll take this so this is run 20. Yeah, I don't think you can do something like lsof-i 5111/gcp.
Yeah. Can do something like that as well. So this basically just prints out if any of the connections change. So seeing as these are all requests that take like a couple milliseconds, so if I would have not used keep alive connections, this whole screen would light up with like new connections being opened.
So this is how you crack it.
So this is how I find out if the keep alive connections are being used properly, because it's really hard to do it some other way, because it's all hidden inside the Go runtime.
What about other things besides keep alive? Like, don't you want to make sure? I don't know. There's a gzip, or I don't know what other optimizations there would be. I guess keep alive is the most important.
Yeah, but gzip and stuff you can usually check in your own stuff.
Yeah,
So.
I was just
So Go doesn't gzip it, response doesn't gzip it automatically for you. That's something you have to do. But the Go client, so here, if it returns a gzipped response here, then and you read the body, you don't have to unzip it yourself. But of course I can see in the headers that it was gzipped or not.
How can you tell when maybe a socket has been stalled or something? I guess the timer at 10 seconds.
Yeah, with the timeout, yeah.
Can we?
With one issue that I have with here a lot, so we also fetch a lot of external requests, and there I see this kind of stuff all the time. So sometimes we do a lot of HTTPS to external services. We have a keep alive connection. They close the keep alive connection because we keep it alive too much, and then they send like, well, an unsolicited response received on an idle HTTP channel.
Alive too long, just because you just use.
Well, you would think like if they support keep alive connections, they would support it for like forever. But apparently there are servers which say like if you keep an alive connection open too long, they kill it, and they do that by sending back an HTTP response while I didn't do a request. So then Go prints out like, hey, I'm getting a response on a.
What API gateway does with the long running.
API gateway has up to 50 seconds.
Yeah.
Always. But your lambda still keeps running after the 30 seconds until the.
So basically, it doesn't actually support keep alive. You say.
No, it supports keep alive for 30 seconds.
Oh, 30 seconds. I thought you said 3 seconds.
But your lambda still runs at the background.
Which means that you cannot do WebSocket.
Can we store in the
Cannot do WebSocket.
Yes.
You don't do WebSockets.
The channel is basically a queue. So.
Yeah. But it doesn't make sense.
Yeah.
And then decue it. It will be more cleaner.
That is what a channel is. It is a queue. I put something in. The way I put the order I put stuff in the channel is the same order as when it comes out. A channel is basically just a queue with synchronization around it to make sure that it's thread safe.
You are dequeuing using the loop, right?
I'm putting stuff in the queue basically, or in the channel, what it's called in Go, and here I was reading from it. So this range loop is like a syntax to read from it. So this for loop reads one item from the queue one by one.
It doesn't have something like queue structure.
Well, it is internally it's a queue, but we don't have like a structure for a queue specifically. No.
I was thinking like put all the list in the queue, then decue 20, not 20. No, decue 20. The queue can only store one item.
Yeah.
The channel can only store, unless you include a buffer.
Yeah. I could write my own queue using less an array or something, but then I would have to write my own synchronization, and this works much easier.
Can you also make that a pull request?
Sure.
I just keen to learn. Do you, hey Ivan, do you do this stuff yourself? Your code?
something like that.
Does Rust have all these prototypes?
Rust have channels. Rust can
Yeah,
source,
I don't know, I
but
don't
can
do
source
Rust.
one is channel, one is HDSC.
Sorry?
Can you source one web application where you have you can show the dependency, you can show the system,
Like how should you structure your application?
yeah.
Ideally,
If you have a really simple application, this is a good structure. Here are his dependencies, which is just a normal standard library.
In a web application, suppose you have a web application.
But this is a web application. It has only not with you mean also with HTML and CSS and stuff in it, or because Go doesn't really have anything for that.
Something like a service where you have the
And normally you would, I don't know if I go,
So you just
like what is this? Yeah, okay.
like how do you follow the best practice based on
For example, for me, this is like this has multiple Go files. It's a big program. I always have a main.go, but you don't have to. And the main.go contains my main function.
where will you set the configuration?
This one, okay, so this one has a main function. I get everything from my environment variable. So here you can see I get like a data center, which I parse to an integer. I get a refresh timer, which I get as a duration. So I get everything from my environment. Main function sets up a whole bunch of stuff, like all kinds of global variables and counters and whatever. Here I start a bunch of loops as well to maintain stuff. So I start a Go function which every minute updates the list of servers and sets count. So here you use atomic as well, as you see. So it sets the server count to the amount of servers that I have. Here every second I update some queries per second counter. That's how you usually do it. Here I have all my dependencies. So in Go, if you import something, you write a full HTTP path. So all of these things, if I just take this, the standard library you can always see is just like 1, 2 things. Yeah, so here this is all standard library stuff. This is all external import. So it's really just an URL. So if I open this, you will see this is like a library for HTTP, which is faster than the standard library.
How do you manage your model?
Sorry, Mike.
is there ORM in Golang?
There are ORMs. I don't use them, to be honest. I'm still a fan of just writing out, like here you can see I have here a really big structure. It's called DSP. It has like all kinds of fields in it. Here I really have a simple. Here I just make a connection to our slave server. I really just do a select statement.
yes, I want to ask you.
And then here it has some scan stuff, so it can automatically, I scan, this is an ID, an integer, it scans it into, so you don't have to write like string parsing function or whatever, but it's just, it's really basically.
What is the scan function you wrote it?
No, that scan function is standard library,
Okay,
like
yes.
database function. Okay. So this one, I have my select query here, which returns here an ID, a state, a name, and then for each row that it returns, I scan like the values from that row into something. For here, I put this in ID, and this in state, this in name.
I think there's some helpers to make this a bit easier.
But-
I just can't remember.
Some what, sorry?
There's some helpers to make this.
There are ORMs, there are definitely ORMs, it's possible, but I prefer to have the least amount of dependencies, and this is really not that much code, I would say, and well maintainable. And I don't like ORMs because sometimes I write a bit more complex queries, and then the ORM tends to like mess up your joins or make like really complex unnecessary joins. So here it has a whole bunch of left joins and whatever. I think if you write it in an ORM, you have the chance that it does the joins the wrong way or whatever, and that you fetch way too much data or make your query way too slow.
So this is the bulk of this advertising thing, grabbing this stuff,
The bulk of
order and then doing the actions or something.
yeah, sort of, yeah. What this does, because you have to respond within milliseconds, you can't do an SQL query within milliseconds, or you can, but not a bunch. So this just, you'll see this load DSPs function. is here executed every refresh, and refresh was coming from an environment variable, so I can say in my config like refresh the data in memory every minute or whatever, and then I use that data in memory actually to do all the lookups and all the stuff.
I see. So it stores the data in memory, and then when it
Yeah.
serves, it's very high speed. So
Yeah.
basically-
So it's this Go process is well, I can see. So this is an RTB sender process. It's called RTB sender. So I have my own tools and stuff. Here, for example, I can see that how many Go routines I keep track of. So sometimes it has like 50,000 Go routines running.
Ooh, wow. How do you plot this?
This is something I wrote myself, so because I like keeping stats, so I have.
How did you?
Is that open source?
Is this GNU plot or something? Or?
No, this is. What is?
Oh, you
What
use
is this? Like Google? No, sorry.
Okay.
You're just grabbing some JSON file or something.
Some Google visualization library is this.
What's the source of it? The JSON you from
Yeah, that I generate myself. That's actually a simple PHP script. So basically, I want to keep lots of counters always, and all the solutions for that I find are way too complex. So I really have here simple like a get counter. You give it a name. This one is just you can just do @1, so it increments the counter by 1. This library automatically flushes the counters to Redis every second, and then I have this simple PHP script which fetches the stuff. So here I can also do, here I said, it's a bit hard to see maybe, but I told it to sum up all the counters for the keys that match this thing with a wildcard here. So if I do, because I wrote it like 8 years ago, when I was still doing a lot of PHP.
This company, you've been there for a very long time.
Yeah.
And
So
now you've been through thick and thin and it's closing up. Oh man, that sucks.
yeah. Sometimes you have to do new stuff.
Were you one of the founders or you just?
Yeah.
Oh really?
Yeah. So actually we were interested in
So you just can't compete with Google and Facebook. They just don't. I thought they might. You know, like I think some companies like Amazon, they're quite good to to their partners. They're trying to farm out things because that's the way they scale, right?
Yeah, but Google and Facebook just dominate advertising because they have all the data on everyone. So everyone, if someone wants to advertise, they go to Google or Facebook because they can do really specific targeting. If you want to target someone who goes to the Golang meetup here, that's possible with Facebook because well, most people are on the group on Facebook. We don't have that data, so it's hard for us to compete. Then you have the GDPR, that new regulation, which makes it impossible for us to track anything unless the visitor basically agrees, and for ad networks that's really difficult. Then you have all the browsers to start blocking third-party cookies.
Did you write a blog about this? You got to write a blog.
There's enough written about this.
Really?
No, you have
So
all
there's a lot of
browsers.
businesses like yours that went out of business.
Yeah, you have a lot of browsers which start blocking all cookies from third-party domains or cookies that are, if you don't have any first-party cookies of a domain, then you can't get third-party cookies. But everyone has first-party cookies from Google.
Controversy because Google Chrome keeps Google
cookies as well. Yeah, I saw today as well. If you clear your cookies in Google, then Google just
Is it blocked by the Firefox tracking protection?
Yeah, Firefox blocks our stuff as well, and it's really hard to compete. But it was fun while it lasted. Yeah, of course. And if you use ad blocker.
Are you going to work in a new company or are you going to?
Yeah, I go to a new company in Amsterdam. I found a job already. Yeah.
I mean, are you going to co-found it or are you just going to work for somebody?
I'm gonna work for somebody. To be honest, I never worked for someone before.
I'll give you 6 months.
In university, I started with a couple of friends. Started a Mini Nova, it's called. I don't know, maybe you know it.
Yes.
Torrent website. We started that in university, so I did.
Did you do pornography too?
I did. My bachelor's took 10 years because we were running Mini Nova, making money, having fun. After that, Mini Nova got sued by like the MPA and stuff, so we stopped with that. We started advertising company. We run advertisements also for the Pirate Bay, for a lot of other torrent sites as well, because we had those contacts. Then we started the advertising exchange here in KL, and so I've never worked for a company.
How many people at its peak was being employed here in KL then?
The company still exists. We still have 2 employees, but just sales. They're just doing sales. So this is like the real-time request for one server. So it's still handling like 2,000 requests per second at the moment. All of them.
How many customers is that? Like one customer or something?
No, that all is everything is it's all through each other. Like a lot of customers still. And so at the moment we're still handling everything combined, like 35,000 requests per second. Still a lot of traffic being handled.
But you're not making money, basically.
But we make just enough money to employ those 2 salespeople, and that's it.
So how many instances running?
Yeah, I'm checking now for you because I knew that was going to be the next question.
Oh, you asked for the bill, what?
Sorry.
Well, enough to pay the sales guys, you were saying.
So those 30 to 35,000 requests are being run on, what was it? It just said it.
1, 2, 3, 4.
11 instances. One of them I saw was starting or stopping. 30,000, 35,000. What was it?
But surely one dedicated machine can do
that many.
requests.
Yeah, if you don't do anything, but this is actually doing stuff, of course.
Oh, what is it? Oh, it's keeping counters. It's keeping.
Yeah.
What are these requests actually? They're bids or?
Most of this is called OpenRTB. It's like a JSON, like you.
You're making bids to buy advertising space or something.
Yeah. So a lot of. We have some websites to implement our text directly, but most of our traffic we get from other advertising companies, which for all their own traffic, they send us a request to see if we are interested in that. So it's mostly stuff like, let's see, this is our interface.
You must have seen a lot of pornography in your life.
It's mostly like JSON like this we get. So this is an impression, it has an ID, there's a banner attached to it. So this is a 375 times 50 banner, so that's like quite wide. This is from our log from just now. So because I log like all the errors, so this is a size we don't support, so it says unknown size. So it was a banner. I can see like it has some attributes that I don't know what for means. I can see this is actually, it's actually an app. So it's this app. I don't know which app that is. Oh, it says here. The Manga Rock app apparently has an app and some user.
So is this real-time stuff like a user's browsing the internet?
Yeah. Well, in this case, an app.
They're calculating a bid for this particular user.
Yeah.
And then showing him that ad.
Yeah.
All in the space of page load or like Assertion or something?
We respond usually within 5 milliseconds, but a lot of people take a lot longer, like 100 milliseconds or whatever. But for us, 5 milliseconds.
5 milliseconds only in North America, right? Because of the Google.
Yeah, of course, yeah.
You don't even bother here because the money's too little around here.
Yeah, also.
So the sales guys are in America, I guess?
No, here in KL.
How come
yeah, we have customers all over the world. And that's so global, the internet.
Yeah, but
who
you
cares?
don't want the sales guys up at 2 a.m. talking to a customer in the US.
Actually,
that's
one of them doesn't do that. The other one is a German guy, and he actually stays up like almost all night to do stuff like that if needed. Yeah.
I'd rather employ someone in the same time zone.
It's more expensive, I tell you. A lot more expensive.
The German guy in KL, he's probably got some demands.
Yeah, some, but this guy, not so much. So, and we get a lot of information here. So, this is the IP address for that user. So, what we do per request, we do a lot of lookups, like check the country that the IP is from, the city, the zip code. Check. Here we have a browser. Yeah, yeah. Here we have like the browser string. So we check which browser it is. We check the size. And then you get stuff like, here I can show some.
So yeah, what was the main way you were selling the customer? Which target metric was the main way people were?
How do you mean target metric?
Like advertisers, I mean, what do you call them? Advertisers? people are looking to target a person.
For
right?
us, this was all the targeting option we have. So you can.
But what was the one that was people were actually bidding for? You know?
Most of them are interested in certain domains. So we have like domain targeting here, or domain categories. We have all kinds of stuff. Yeah, so this is all kinds of countries, cities, zip code, languages. This is DMA, some US thing, carriers, connection types. So I can connect.
And how do you make sure that you're serving this within 5 seconds?
By writing really good Go code.
But
5 milliseconds.
what happens if it's longer? Do you have some sort of cutout or?
Yeah, but the cutout is usually 100 milliseconds, so we are like way below that.
You plotting, do you have
I have that also somewhere.
Your request per second, request,
Um,
what do you call this? Time of request.
yeah, I can plot that, let's see.
Because I find it difficult to comprehend you doing it by page load. You have to keep a cookie, don't you? And you basically.
Yeah, there's also a cookie with a user ID.
Pages.
And you have, more interesting is, so you have a lot of campaigns running, and campaigns can say like here in the targeting, I only want to show my ad to a certain user only 1 time per day, for example. So you also have to keep track of which campaigns you've shown to which user at which time. And then for every request, we fetch basically, every request has a user attached to it. We fetch the data for all the campaigns they have seen and then run that against the list as well.
That's kind of
And
crazy.
then you have to.
Which database did you use to keep it?
No, it's all in memory. All in like maps and Go. You saw just.
That's when you're using during runtime, but you store this eventually in batches to the database.
The database itself is in MySQL.
Okay.
But not the reporting. Like the reporting we have as well.
It's like a daily
The reporting is pushed into Kafka, if you know that. It's like a message bus, and then into something called Druid, which is written in Java, which is like real-time reporting. So I can also see here.
So it's real-time based on the messages you send out.
Here I can run a buy-side report, for example. So I want to know how many impressions there are bought today per hour and how much people spend. So you can actually see that we don't make that much money at the moment. So this is actually a report per hour with a graph with it, how much people spend. So almost nothing per day. And this is actually also real-time reporting. So if I refresh this, you will see the impressions number is going to change. It's a bit slow now. I don't know why. I don't know if the internet is slow or reporting is slow.
Is never real-time.
It's always when you demo something, it goes wrong. And because we had to cut on server costs, I had to cut on reporting servers.
So basically this chart has just been slowly going down or something?
Yeah, basically.
Was there some moment, like back in 2012, where things changed?
No, it's sometimes, it's just going up and down and up and down.
But the trend of the last...
But the trend from the last year, I think.
How much does the server cost?
We spend about, I think, $8,000 US a month. Yeah.
A lot.
8,000 is almost
Not
nothing.
that much, actually. I mean, I work for startups that spend way more money than that.
We handle, I don't know why it's not working now, but so we handle like 35,000 requests per second. We generate like a couple gigabytes per day in just reporting data.
How do you, for your structs, how do you know how much memory they take? Is there good tools to work that out? You
know an integer takes 8 bytes and a pointer takes 8 bytes and a byte takes 1 byte, and I don't know that. I have to say here, if I run like top and I check the CPU.
I thought you might use some tool.
So okay, so the receiver, which is like receiving like those 2,000 requests per second, it uses 1.5 gigabytes. It's almost nothing.
Sounds like a lot. I mean, what's the structure?
I think most of that is actually that lookup table to go from IP address to like city or zip code even.
Oh, you've loaded
the whole thing. Yeah, that's the whole thing is in memory, of course.
Is that inside Go's memory?
Yeah, inside Go's memory.
So you're not using something like Redis to make requests to Redis?
No, because that's a bit slow, yeah.
Just
and that's actually, because Go is garbage collected, so if you, of course you can make like a big lookup table with like an array or a map or whatever, but if you do that for all the IP addresses. That's a lot of data that the garbage collector needs to check and whatever, so it's slow. So for that I actually wrote some custom code where we have like a huge memory mapped, a huge array of bytes in memory, and then I manually encode everything in there and whatever. There's a lot of... Normally, I would say if all you guys knew Go, I would do a lot of tips on how to boost your performance of Go programs, because if you write like normal, simple Go stuff, then you can't handle this many requests per second.
On the other hand, today the amount of things that I've learned, I wouldn't be probably learned that thing in 1 month, you know. So yeah, it's just I missed you.
Yeah, you've definitely taught me lots of stuff. So,
Thank you.
You were saying though, if you load up a big structure, isn't there some primitive to say don't look at this for garbage collection?
No.
So you get around it by encoding it or something?
Yeah, that's because this would generate like thousands and thousands
How
of...
do you encode it so that it doesn't get garbage collected? I didn't quite follow.
I basically make it as one big array of bytes, so it's only one pointer that Go has to keep track of for garbage collecting.
So basically ignore
and then IP addresses you can encode to an integer, and then you basically do a lookup, sort of like it's a bit of a binary tree sort of idea. Yeah.
So if Go had these primitives to control garbage collection, that would make things a lot simpler in code, right?
On the one hand, yeah. On the other hand, I can see people abusing that and making code a lot more complex to read for someone, because now they, instead of having to rely on the garbage collector and just knowing that stuff gets garbage collected, you don't know anymore if it gets garbage collected because someone somewhere else in the code might have used that primitive or whatever. So I think that would introduce like a lot of memory leaks, so it's not worth it.
Eric, I have a basic question. So if I were you, I would probably create a struct with different values inside of it, and then make an array of struct, like the...
Yeah, but then still there's so many IP addresses or so many ranges that you still get a lot of...
Right, then I would probably write a function that will go through the list and find it's like a basic lookup inside. But how did we do that? I think we should create some kind of simple open source project to just practice that.
I didn't quite follow what you're looking to do.
It's
track IP addresses into a map.
So what I have is basically a big array of 32 bits integers. So that's IP addresses that start. They are sorted on the number. So it's basically a binary search. So you start in the middle, and then if the IP address is lower than that point, and then you just do a binary search.
That's why we can do binary search.
Yeah, so you just do a big binary search, and then I have an array of pointers of the actual data. So I find like the index in my start and end, and then I use that in this, and then
I have IP addresses that you've seen in this map,
And then here I do have a node struct, but because I don't want to keep like a whole array of a lot of those node structs, I actually encode it. So if I read it from like a byte slice, and I read like really like little endian encoded integers out of that byte slice. So the first 2 bytes are the country ID, the second 2 bytes are the ISP ID, blah, 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 etc., etc.
Almost binary operation.
You started this company 10 years ago, right?
No, this company was started 5 years ago.
Okay, so you started with Golang and...
Yeah, like 5 years ago.
Yeah, this is pretty hardcore when using these primitives.
And today I would show stuff like even lower, because I think
16 bits.
this I see now this could actually be this is not performance sensitive though, so it doesn't have to be faster. But for today I had stuff prepared like this is funny. Yeah, bounce checks. So if you have a function that reads like certain things from a byte slice, so I have here a byte slice, and I want to, I put it in the byte slice in this case. So this actually writes a 46-bit integer into a byte slice, so every byte separately. This is of course quite fast, but in Go and in many other languages, at this point it would check, oh, is that byte, you don't know the length of that byte slice, does it have 1 element, does it have 2 elements, does it have, each statement here will insert like what's called a bounce check. It checks if that index into that slice if within bounds, if that slice is big enough. And that's slow. So here, what you actually do is here you assign byte number 7 to nothing. So it's an empty statement that doesn't do anything. But now the compiler sees, okay, byte number 7, if this statement doesn't panic, it exists. So here, if I'm going to write to byte number 0, I already know that 7 exists, so 0 also exists. I don't have to add any bounds check. So this statement, this function, has 1 times the bounds check to check if there's enough elements, and then all these are fast again. Now we have a different one. We can also write it the other way around, of course, you think. So I start at 7 and I go down, then it doesn't have to insert any bounds checks either. But, and I don't know why, go testing bang.
Oh, yeah, that's the next question I wanted to use. You use benchmarks.
Yeah, I use Go bench a lot. So here you see without that bench, that bounce check in the start, it takes like about 5.4 nanoseconds to run that function. If I do the bounce check in the beginning, it takes 2.4. But the one that I call different is still, it's a bit faster than the without one, but it's still a lot slower than the with one. So this one, you would also say, like here, it does a bounce check for number 7, and then all the other ones are not needed. Still, it's slower. To be honest, I don't know why. That's one thing I still want to find out. I'm thinking, because you write it in reverse order here, it has to do a different statement for each one, while with this one, it can probably combine all 4. I would probably do something like this to find out PC.
I guess the compiler is too difficult to read.
How do you display
I hope I would do, yes, exactly. Flags minus S, I think. Okay, so here we can see.
Is there IR for Go?
A what for Go?
IR.
What's? Yeah, this is the Go IR you see here now. Okay, I'm going to.
This is IR. This
Oh,
the
wait.
The Go, it's not assembly as in machine, it's IR assembly.
Okay, so benchmark without. So with benchmark without, you see probably. I don't know, I'm not familiar with Go assembly, but I'm thinking this is without. I don't know, I would expect to find like 8 statements here for each entry, but it doesn't do that. I don't know why it doesn't do that. And then the with one, apparently not. No, okay, so I can't see anything here. I expected 8 statements and then, no, my assembly skills are not that good that I can do that here right now.
Okay, thank you so much. Maybe next time.
No problem.
See ya, bye.
Maybe I'm here in November still.
11 now. It's 11 now, by the way.
Okay, I guess we should go.
Yeah.
How long are you left in KL?
The new company I work for is flying me to the Netherlands in 2 weeks. No, in 2 weeks, just for 1 week to start working for a bit, and then I fly back here. Then me and my wife are going to India, Nepal, Myanmar.
What way? Third poverty tourism?
It's the countries we haven't been yet.
Oh.
We have been to a lot of countries.